Now, in this video, we're going to answer the following question. Express this complex number in the form r multiplied by the cosine of theta plus I multiplied by the sine of theta. And we've been given the complex number 7 minus 24i. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. A complex number is a number of the form a plus bi, where a and b are real numbers, with a representing the real part of the complex number and b representing the imaginary part. The form z equal to a plus bi uses the Cartesian coordinates of the complex number a, b. A complex number can also be written in its polar form using its polar coordinates r, theta, where r is the modulus and theta is the argument. The polar form of a complex number is z equal to r multiplied by the cosine of theta plus I multiplied by the sine of theta. The modulus of a complex number is the magnitude or distance from the origin to the point representing the complex number on an Argand diagram, and is derived from Pythagoras' theorem. The modulus is a positive real number. Finding the modulus of a complex number is a three-step process. First, we need to square the real and imaginary parts of the complex number. Then, find the sum of those values before taking its square root. The complex number we've been given is 7 minus 24i, and we're going to call this z. The modulus of z is equal to the modulus of 7 plus minus 24i, which is equal to the square root of 7 squared plus minus 24 squared. And 7 squared is 49, and minus 24 squared is 576. So, we need to find the square root of 49 plus 576, which is equal to the square root of 625. The square root of 625 is 25. So the modulus of z is equal to 25. the argument of a complex number is the angle made with the positive real axis on an Argand diagram. Finding the argument of this complex number is a two-step process. First, we'll draw the complex number on an Argand diagram to see what the complex number looks like. Then, forming a right-angled triangle, we can use standard trigonometric ratios to find the size of the acute angle in radians between the complex number and the real axis. To begin, we're going to draw the complex number on an Argand diagram. The complex number z equal to 7 minus 24i has a real part equal to 7 and an imaginary part equal to minus 24. Plotting the value 7 on the real axis and the value minus 24 on the imaginary axis, and drawing a line representing the complex number, the angle formed between the complex number and the real axis is alpha. To calculate alpha, we're going to use the right-angled triangle that has been formed and apply trigonometric ratios. The trigonometric ratio we need to apply is the tangent ratio. And the tangent of alpha is equal to the opposite side divided by the adjacent side. In this case, 24 divided by 7. By applying the inverse tangent function to 24 divided by 7, we get a value of alpha equal to 1.286 radians. The principal argument for a complex number in quadrant 4 is a negative value. In other words, theta is equal to minus alpha. So, the principal argument of z is equal to minus 1.286 radians. Substituting the values for the modulus and argument into the polar form of a complex number, we get z equal to 25 multiplied by the cosine of minus 1.286 plus I multiplied by the sine of minus 1.286. So, the complex number expressed in polar form and the answer to this question is z equal to 25 multiplied by the cosine of minus 1.286 plus I multiplied by the sine of minus 1.286. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.